One critical aspect of test management involves completing the loop with defect fixes and source code control. It's all very well raising defects as part of the test process, and it's also good to know that those defects have been fixed. But to be totally in control, you need to know what and how those defects were fixed. And typically this means linking your defect tracking system into your source code control system. In the example we're going to look at now, we're going to see how we integrate QA Complete into a subversion instance that's running on a CollabNet cloud-based setup. So what we have here is QA Complete or ALM Complete for test management and defect tracking, and here we can create test sets, and when we raise defects they're listed within ALM Complete. We also have an integration tool called OpsHub, and this is set up so that subversion check-ins are synchronized and provide traceability records within QA Complete. That integration then works in this instance with a CollabNet CloudForge setup which has subversion configured. And for the purpose of this demo, we also have a subversion client running on a Unix machine so that we can modify our source code files and check in changes to our subversion repository. So what we're going to see today then is regression test sets run from within QA Complete, where we might run 6 or 7 test sets. They result in a defect that is created within QA Complete, and that defect will be assigned to a developer, and as a result of that defect he's then going to make changes to the source code, check those files in to the source code repository on CloudForge, and those check-ins will show up within subversion here, our subversion repository residing on the web. Here, and in this example we've just got a few files that are making up our subversion repository. When those check-ins take place, what we'll see under the defect records within QA Complete is that those check-ins result in traceability from the defect to the subversion check-in, so we can see exactly which files have been checked in to resolve a defect. And thus we can confirm the fix, retest the fix, and move the defect into a resolved state. So let's see this example in practice then. First part of the process, we're going to pick out a regression test set within QA Complete. This test set has 9 tests that we need to execute, and when we run that test set for a particular release, maybe version 2 on a particular config, we can start to execute the first out of 11 test cases. We'll run this test, and it might be that this first test we pass the first test step and we fail the second test step. Now with QA Complete, when we fail a test we get the chance to automatically create a defect, and in this instance we're going to say yes. And the advantage of creating a defect automatically is firstly that QA Complete pre-populates a lot of the information from us, like title, and also the defect starts out with traceability back to the configuration the test was run against, the test that was run, and the release it was being run against. And later we'll see how this is then added to with the subversion check-in. So we'll complete this defect by assigning it to a particular developer to resolve, and set a priority which is mandatory here, and submit the defect. I'll just quickly end the test run. That's failed. And when we look within the defect area of QA Complete, we'll see our new defect at the top of the list here. And as this has been assigned to a particular developer, that developer is aware of the issue, would then resolve the issue and check in the source code changes. So in this instance, the developer may come into his source code repository, and in this case we have just a number of text files. He may update several of these files within his source code. And in this case I'm just using Vi, but this might be any other developer IDE environment. I'll just make one more change to another file. And at this point, with the changes and the fixes made to the source code, the developer is in a position to check those files back into, in this case, Subversion running in the cloud. Now, for a check-in to Subversion to work correctly, we have a comments file in this instance, and I'm going to update that comments file with two things. One, the comment related to the fix that we've made, and the other a reference to the defect within QA complete. So if we come back in here, we can see that we have a defect ID, and if we copy that ID, paste that in here, and it's this ID that allows the Ops Hub integration to link the check-ins to the defect in QA complete. So we'll then check that defect in. So we've got Subversion, check-in. We'll use the file CI comments for the comments and the defect link, and then we'll check in the two files that we modified. Now those two files have been checked in, and with our Ops Hub integration setup, which links Subversion to QA complete, what we should see is an update any second now to the revision that's shown here. So you can see now that that's rolled to check-in 12, which correlates to our committed revision 12. Now the Ops Hub part of this equation runs in the background, so typically you're not going to be looking at this. What we would see though is within ALM complete, if we come back and relook at this defect, is that there is now traceability not only to the test, requirement, config and release the defect was raised against, but to that Subversion commit. And we've done one commit in this instance, and that commit made changes to two files in our Subversion repository. So again, within this process, the developer is going to resolve the defects, maybe put some resolution information in there. Moving the defect to a resolve state, and perhaps even assigning now to the tester that's going to pick up this resolved defect and run the retest. Now the last part of this process that closes the loop then is for the tester to pick up this resolved defect and check and confirm and verify that that defect has been resolved in the next release. And a nice feature within QA complete is that we can come in, view the resolved defect, and if necessary just quickly create a linked test to the defect. So what I've got here is a new test case that we're adding to our test library. Test case to check the defect that we fixed, and notice that when we do this again, that the new test we're raising is automatically linked back to the defect for traceability purposes. And this essentially closes the loop from our initial test, which raised a defect, which resulted in a check-in, which then has traceability to the defect again, where the tester can then verify the defect fix by running a retest. Essentially, we're in total control because we know exactly what and how that defect was fixed.